Good morning, everyone. How are you all? I hope that all of you are doing amazingly great. Today, I am back with an important class for you. Today's class is very helpful class for both Bengali medium and English medium students. Okay. In this class, we will solve the previous year question paper from the function or mapping chapter. Okay. If you want to know about this chapter, you can watch our previous classes. You can find our previous classes in the description box below. So let's get started. Okay. First of all, we solve an important question which has come repeatedly in the exam. Okay. This is very important question. It is given that let A set up all x such that x belongs to set of real number such that -1 less than or equal to x less than or equal to 1, and a function f maps A to A be a mapping defined by f of x is equal to x mod x. Then choose the correct option. F is injective but not subjective, surjective but not injective, neither injective not surjective, and injective as well as surjective, that is bijective. Okay. So let's get started. Here f of x is equal to x mod x. We know that mod x or modulus x is equal to x whenever x greater than 0. And this is 0 whenever x equal to 0. This is minus x if x less than equal to 0. Then f of x becomes x into x square if x greater than 0, 0 if x equal to 0, and minus x square if x less than 0. If we put x is equal to 1, then f of x is equal to x is equal to 1, so this is greater than or equal to 0, so outcome is 1 squared is equal to 1. And if we put x is equal to -1, then since x is -1, that is less than 0, then output f of x equal to -1 square, that is -1. We can easily solve this problem with the help of a graph. If we draw the graph of this function, then we get this x o x dash, y o y dash. Okay. The graph of the function is this. A question may come out our mind, how to the graph was drawn. Okay, this is very simple. If we put x is equal to 1, 2, 3, etc., then become output is f of x is equal to 1 square, 1 2 square, 4 9, etc. And if we plot the point 1, 1, 2, 4, 3, 9 in the graph, then we have this. Similarly, if we put x is equal to -1, -2, -3, etc., then outcome will be f of x is equal to -1, -4, -9, etc. And if we plot this point 1, -1, -2, -4, -3, -9, then we get this. If we draw a line in anywhere of the graph, then the line cuts the graph at only one point, this and this. So this is an one-to-one function. Is it clear? Okay. So this is one-to-one function, that is injective. Okay. And we clearly say that there is an image for every values of x. There is an image for every values of x. So this is surjective or 1-2. Surjective or 1-2. Hence, we have f of x is equal to injective as well as surjective. Then this is bijective. Okay, so here D option is correct option. That is, the function is bijective. Okay, now we will discuss the next question. Okay, now we will discuss the question number 2. Please follow this. Here it is given that let A is a set which contains 3 elements 1 to 3. Okay, and B is a set which contains the 4 elements 4, 5, 6, 7. And A relation or function 1, 4, 2, 5, 3, 6 be a function from A to B. Based on the given information, F is the best defined as injective, surjective, bijective, or none of the above. Okay, we can easily solve this problem with the help of the diagram. Okay, set A which contains 3 element 1, 2, 3 and set B which contains 4 element 4, 5, 6, 7. Here we see that 1 maps 4, 2 maps 5, 3 maps 6. Okay, each element of A has only one preimage. So obviously this is 1-to-1 or injective. Okay, and we can clearly say that the element 7 in the set B which has no preimage in A. Okay, 7 elements of 7 has no preimage in the set A. So this is not surjective. So surjective or surjection. So the correct option is A. This is injective. Okay, this is injective. This is correct answer. Now we will discuss the next question. Now we will discuss a very important question. Okay, follow this. So that a function f maps natural number to natural number is given by f of x is equal to x plus 1 if x is odd and x minus 1 if x is even is bijective function. Okay, we have to show that f of x is bijective function. Okay, when a function is said to be bijective, a function f is said to be bijective if it is injective as well as surjective. Okay, so for injective or 1-to-1, let x1 and x2 be 2 elements belongs to natural number such that f of x1 is equal to f of x2. If x1 and x2 are odd, then we get this odd. x1 plus 1 is equal to x2 plus 1. 1 out, then it becomes x1 is equal to x2, which implies that f is 1-to-1. Similarly, if x1 and x2 belongs to natural number such that f of x1 is equal to f of x2, if x1 and x2 are even, then it's become x minus 1. So this is x1 minus 1 is equal to x2 minus 1. Okay, minus 1 out, then it becomes x1 is equal to x2, which implies that f is 1-to-1. Okay, now for 1-to or surjective, for even y belongs to natural number, even y, then we have y minus 1 even is equal to x minus 1. So this is y minus 1 is equal to x, which is a natural number. So f is 1-to-1. And for y is equal to what? Then we have x is equal to y plus 1, which is belongs to natural number. Hence f is 1-to-1. Then we have f is 1-to-1 and 1-to. That is injective as well as surjective. So f is bijective. Okay. Also, we can prove this problem with the help of diagram. Okay. Here set A and set B, A mappings which moving from A to B. A contains 1, 2, 3, 4, 5, 6 elements and B contain 1, 2, 3, 4, 5, 6 etc. Okay. 1 is what? So output is 1 plus 1 is equal to 2. So 1 maps 2. 2 is even, then 2 minus 1 is equal to 1. So 2 is 2, output is 1. Okay. If we take x is equal to 3, then 3 is what? So this will be x 3 plus 1 is equal to 4. So output of 3 is 4. Similarly, output of 4 is 3, 5 is 6, and 6 is 5, and months work. Okay. So this is 1 to 1 and 1 2. Okay. So this is bijective. Now we will discuss an important question. Okay. Follow this. If n of A, that is the cardinal number of the set A, is 4 and n of B is equal to 3, then find the total number of functions from A to B is. Okay. Here two cases may arise. Case number 1 is equal to the total number of functions from A to B is n of B power n of A. Okay. Please remember this. N of B power n of A. That is 3 to the power 4. 3 to the power 4 is equal to 81. So the total number of functions from A to B is equal to 81. Okay. And the total number of functions from B to A is n of A power n of B. That is 4 to the power 3. And 4 to the power 3 is equal to 64. Okay. A to B is 81 and B to A is 64. Okay. Next, if n of A is equal to 4 and n of B is equal to 5, then the total number of one-to-one or injective function is dash from A to B. We know that the total number of one-to-one or injective function from A to B is n of B P n of A, that is 5p4. Okay, 5p4 is equal to 5 factorial by 5 minus 4 factorial. Since we know that npr is equal to n factorial by n minus r factorial. Here n is 5 and r is 4. Okay, so 5 factorial by n minus r, that is 5 minus 4 factorial. Okay, 5 factorial means 122 and 5 minus 4 factorial means 1 factorial. 1 factorial is equal to 1. So the correct answer is 120. Okay. Hence the total number of one-to-one function from A to B is equal to 120. And from B to A, that is 4p5 is equal to 0. Okay, the total number of one-to-one or injective function from B to A is equal to 0, and from A to B is equal to 120. Okay, that's all for today. Thank you everyone. We will meet again in next class. Thank you.